solve the differential equation y prime prime minus y prime minus 2y equals 4x squared. So we can see that this equation is a second order differential equation, and also is a constant coefficient. But then because it is not homogeneous, we termed this f of x to be not homogeneous, because this f of x is not equal to 0. So if f of x is not equal to 0, then it means our differential equation is a non-constant homogeneous differential equation. Okay, so in this case you will have two solutions. You have the one for the left hand side and also another solution for the right hand side. The one for the left hand side is the complementary solution. So when the whole of this is set to 0, we will find my root. Then also the second solution is the right hand side too. That one too, the solution is called a particular solution. Okay, so quickly, to solve the left hand side, we learned from our previous video that when we are interested in making a substitution when we have equation in a form this. So when you have equation in the form second order, we will try to make this substitution to reduce the second order to a quadratic form, so that we solve and get the values of r. So we made this substitution that y equals e exponent rx. So we differentiate my y with respect to x. So I know that when I differentiate rx, I am going to get rx. Then when I differentiate this one again, that's the second derivative, I am going to, the r will come down and multiply r, getting r squared. Then we maintain e exponent rx. We are doing this because, you see, it was a second order and the first order. So we differentiate it first, our first order, then we differentiate it twice. Then after that, we make a substitution. So wherever we see y, we substitute this into these equations. So making the substitution, we are getting r squared erx minus the y prime, and the y prime 2 is re exponent rx minus 2. This is the minus 2 times y, and this is the y, e exponent rx equals 0. And then we try to factorize e exponent rx from the equation. So we are going to get r squared minus r minus 2 equals 0. Then after that, we try to solve this quadratically. So we all know how to solve a quadratic equation. Two numbers when multiply, you get negative 1. When you multiply, you get negative 2, and when we add, you get negative 1. So I did that, and I had my r to be equal to 2 and minus 1. So it can be seen clearly that, my values of r, my values of r is 2 and minus 1. They are rare and distinct. And from our previous video, we saw that if the root is rare and distinct, we will use this form. So the general solution will be in this form. That's the complementary solution, the complementary aspect. That's C1e exponent r1x plus C2 e exponent r2x. That was just by the way. That was from our previous lessons. So what we are interested is that we first try to take our trivial solution from our right hand side. So what will be our trivial solution? Trivial solution. So we are going to this is how we choose the trivial solution. So our trivial solution will be in a form this. So just keep in mind it is in the form y particular equals x exponent k multiplying ax squared plus bx plus c. I wrote ax squared plus bx plus c as my trivial solution because it is a third order. That's when we have f of x to be in the form when you have f of x. So this is termed as the f of x. So when we have f of x to be in the form ax exponent s. So the x can be any integer. So this is my x, this is the x. A is a constant, which is the 4. And this is x, the integer, which is 2. So it is having a higher order or degree of 2. So we term as a quadratic. So from basic school or from SHS, we know that when we have a quadratic in the sense that it can be written as ax squared plus bx plus c. Okay, so all the terms that comes after the x squared is hidden. So you have to write it. That's how we take our trivial solution. So we write it as ax squared plus bx plus c. Then x exponent k. So the k is a multiplicity. It is just the multiplicity. Multiplicity in the sense that when we have the r, the solution to be when we have the trivial solution or the r, we had 2 and minus 1. Okay, so if r, there's a condition we have to know. If r equals 0, it's not a solution. If r equals 0, it's not a solution. Then my k is 0. Bear in mind, if r equals 0 is not a solution. So let's see whether I can find it here. Okay, so let's see. So for the y particular, these are the constant that holds, or two things that we need to know. If the r equals 0 is a solution, then my k will be 1. But if my r equals 0 is not a solution, then my k is 0. So we can make a substitution. So we know that we wrote the trivial solution in this form, but because the solution we didn't have, or we had no 0, or we had the answer to be it was, I think, minus 1 and 2. From our previous solution, we saw our r to be minus 1 and 2. Where is it? Okay, minus 1 and 2. You see, because it is minus 1 and 2, r is not equal to 0. The solution doesn't include r. It doesn't include 0. So if it doesn't include 0, then my k is definitely 0. So all that you need to know is that, okay, so my k, which will be 0, so we make a substitution here. So my yp will be, because k is 0, x exponent 0 is 1. So 1 multiplying the whole of this, we are getting ax squared plus bx plus c. Okay. Then after that, we try to solve for the particular solution, because the equation was a second order, we differentiate this first time, then we differentiate it second time. So my yp, or the particular solution, is this. So we are doing the right hand side, because the left hand side is easy. That was the complementary solution. So my particular solution, that's the right hand side. We differentiate my trivial solution. So you know that when I differentiate this, we are going to get the 2 will come and multiply. So we're going to get 2ax. Then with respect to x2, the x will come and multiply. You know that when you differentiate x, we are going to get 1. 1 times b is b. Then anytime you differentiate a constant, is 0. So then we differentiate these 2 again. So differentiating this, we are going to get 2a, because when you differentiate x, we are going to get 1. 1 times 2a is still 2a. Then we make a substitution into the original equation, y prime prime minus y1 minus 2y equals 4x squared. So let's forget about the right hand side. We are interested in the left hand side. So we will do the one for the right hand side. After that, we compare. So we try to substitute. So whenever I see my y prime prime, I'll substitute 2a into the equation. So my 2a minus y prime, by my y prime is 2ax plus b. So 2ax plus b minus 2y, so minus 2y, but my y was this, the whole of this. So I make a substitution. Then I try to simplify. So after minus 1 or the negative will multiply through this, giving us this. They will multiply the whole of this 2 by 2, giving us this. So then here the idea is that you try to collect all the terms of the x squared to stand alone, all the terms in the x squared. So looking at this equation, only this is the term with the x squared. So you try to make my minus 2ax squared come. Then you try to make the terms with the x2 come together. So the terms with the only x, so only x coming together. Then we try to factorize my x out, so leaving 2a minus 2b. Then all constants, all values without x or x squared, that's the 2a, 2b, 2c, all the constants, to regroup them. So we are doing this so that it will make our solution easier. After that, we try to compare my values of the left hand side to the right hand side for x squared. So we know that, you see, here we had minus 2ax squared. So when you compare minus 2a squared to 4x squared, we are going to get minus 2ax squared equals 4x squared. So my x squared is going to cancel x squared. When we try to find the value of a, that is divide 2 by negative 2, we are going to get a to be minus 2. Then also, you know that this place to the whole of this, that's minus 2a minus 2b equals 0. It is equal to 0 because, see, all the values of the right hand side is only 4x squared. It's only 4x squared. So the other terms will be plus 0x plus a constant, or plus 0. So you know that, you see, my right hand side is only the 4x squared which is appearing. The rest is 0. It's not appearing. So meaning my one with the x, comparing the coefficient, 0 will be equal to the one in front of the x. Okay, so that's how we equated this to 0. Then we try to make a substitution, because you know that a we had minus 2. Then we make a substitution here. Then we try to simplify it. So my b, we are going to get b equals 2. And also we try to find the value of C. And also, as I said, the C component is 0. C is 0. So 0. Then I know my value of A to be minus 2. I know my value of B to be 2. So I make a substitution, then I'll make C stand alone. Then we are going to get C to be equal to minus 3. Then after that, I already know my particular solution for the differential equation. So my particular solution, I wrote it in the form ax squared plus bx plus c. So after getting the value of a, b, and c, you substitute it back. So we substitute it. So my a is minus 2, my b was positive 2, then my c was negative 3. So negative 3. Then after that, my complementary solution from case 1, we know that when the roots is rare and distinct from our previous videos, if the root is rare and distinct, then I would show this the root. If the root is rare and distinct, then my complement or complementary solution will be in the form C1e R1x plus C2e R2x. So we make a substitution. You know that you are going to get e exponent. The R1 was minus 1. You saw that our R1 was minus 1. Our R1 was minus 1. Then also our R2 was, I think, 2. So you make a substitution here. So wherever I see my R is minus 1, by its multiplying x, we are going to get this. So my general solution will be the addition of the complementary solution and the particular solution. So my complementary solution, I had this. So you write it, then you add it to the particular solution, which is this. So this is the general solution for the differential equation. Thank you very much.